This is just kind of a quick reference sheet. All right, it's kind of one of these, if you see this, this is what you should do. Some of them are actual numbers, and some of them are actual letters that we're going to put in there. So this is what I mean. If you see a central angle, right, that's a central angle, you're going to immediately think, well, then that arc, so we're going to go through this pretty quick, that arc EF is going to equal the same thing as the central angle. So it's going to be 65 degrees. All right, so anytime you see a central angle, you should immediately go, I can name that arc, because you probably have to. All right, the one down below it, actually, let's go to the right really quick. Let's go to that one. All right, now this is an inscribed angle. So in this case, measure of arc AB will not equal 34, but it's going to equal 2 times 34, which is going to equal 68 degrees. Now we'll come back to this one. We did have an explicit rules to this. We said if we have an inscribed angle of a diameter, it's going to be 90 degrees. But you can also think of it this way. Well, this is a diameter, so this must be 180 degrees. And since it's inscribed, it has to be half of 180 degrees. So either you remember the rule, or you can just go measure of angle C equals 90 degrees. Either you remember the rule, or you just remember that it's 180 degrees and it's half of 180, which equals 90. Either way, you're good. All right, this is that weird one that we sometimes have a hard time seeing. It is when we have kind of that chord and that tangent to the chord. Note the chord does not go through the center. So since it's not going through the center, we're going to treat it as an inscribed angle. In the fact that this arc right here is 196. So this, I think I have E there. Let's put it earlier on here. So the measure of angle E is going to equal 1/2 of 196. So that's going to equal 98 degrees. Don't forget about that one. That kind of buries itself into a problem. All right, because it's hard to see that it's actually an inscribed angle, because it really isn't, but it still follows the same rule as an inscribed angle. All right, continuing on. If I see two parallel chords, and I know the measure of one of the arcs, I know the measure of the arc on the other side. So D is going to equal 78 degrees as well. All right, down here, if I see something going to the center and it going through a chord and it's 90 degrees. So we're looking for two things, but the big thing really is this 90 degree. That's what I'm looking at right here, these 90 degrees. Well, if they go through 90 degrees, I'm looking at the fact that they bisect the chord. In fact, I should change this one. I'm going to change this one because we do not know these chords are actually the same length. We don't know those chords are the same length right now. So all we know is that this bisects and this one bisects. Can someone tell me how I don't know the chords are the same length? And the hint is the next one. Yeah, Evan.
Isn't it because it's like you don't know like the measure of like from the center of the circle?
Yep.
Or not the measure, the length.
No, I know what you meant. Yep, I got you. The only way I know that, so right now this is all I know. This right angle, all it says is it bisects. What Evan was talking about is this next one right here. I'm going to skip to this one because it's very similar. If I see these, then I'm going to think, let's go ahead and label these. I'm going to call this A, B, C, D. Now and only now do I know that, what was that? Are they labeled on yours? It just didn't copy. What did I label them as? Sorry. L. My labels must just not have pasted on here. Yep. Nope, they are. They probably just didn't copy to my Word document. So we have L, K, H, and E. Were they labeled on mine?
And then J and F. G.
I just want to see why they're not on this one. If they're on mine, they'd be on. Yeah. No, okay. Yeah. So really, what I'm looking at is these signs. And these signs, coupled with the fact that they're 90 degrees, is going to tell me that LK is congruent to HE. In fact, we know a little bit more. We also know that this segment is congruent to that one, so it still bisects. And in fact, all of these would be congruent as well. Maybe I'll throw that on there, that this would be congruent to this. This would be congruent to that, but that follows from the other one. If we see something like this, two chords are congruent. The arcs they subtend are also going to be congruent. So that means the measure of arc BA, or AB, it seems better because it's alphabetical, is going to be equal to the measure of CD. All right, so two equal chords mean they subtend congruent arcs as well. Yeah?
Wait, so in this circle, like below, like the LK, E, and H?
Yep.
It's like all of like the lines are like equal then?
Yep. So these chords would be equal, right?
Like, are they equal also to like the center one?
Are these equal to the center ones?
Yeah.
No, that's why I put two dashes on them. And actually, you can kind of picture, I can move this one, right? I'm allowed to move this. So let's say the line is here instead. And that means I'd move this line here. And these lines would extend, and I could still do a 90 degree. My snap tool is not on point right now. Do those look like all three of them would be the same? No. No, we do not know that. Basically, everything I have on here is what we know. But what you could do, and maybe because I have a lot of stuff on here, maybe I'll put it on the one before it. What you could think about, Akshay, to get those sizes is just recall that this, if you draw a line here, that would be your radius. And now you have a right triangle where if you know the radius, or if you know either one of these two values, you can get this value. All right, that's how we get our radius. So that's where those sizes come in key. But not all two, both of them aren't the same in that one. But don't forget about drawing that triangle. That was big in one of the assignments. You have that actually on some of your problems today, too, that I'm handing out, that you have to know how to find that radius. All right, continuing on. This one's pretty easy. So I have a quadrilateral inscribed in a circle. So that's just going to tell me that the measure of angle F plus the measure of angle G equals 180 degrees. In other words, they're supplemental. Coming down to the next one, we just did this, basically. When it's inside, you add and divide by 2. So this is going to be our H equals 1/2 of 74 plus 32. And since we're adding, it could have been 32 plus 74. It doesn't matter what order you do it in. All right, we're continuing on. That top right one, I want you to think a few things on this one. So the first thing I want you to think about is these segments here are congruent. Did I put labels on yours on that one?
No.
No? Okay.
Just had the measure of
Yep.
the angle is A. Like the far end.
I must have an old copy. Oh, yeah. I think my letters just didn't paste on here, so we have A here. All right. So what I want you to think about is because we have two tangents, those two things are congruent. Also, because it's a tangent going to the center, this is going to be 90 degrees. So that's going to be 90 degrees. And to solve this, we're not actually going to solve it, but you would just create two right triangles. All right, but your big things are there is tangent lines that meet outside are congruent to each other, and tangent lines connected to a line or a chord that goes to the center is 90 degrees. Note, that's a big difference than this one because it doesn't go through the center. This one doesn't go through the center. This one goes through the center, so it is 90 degrees. And if you think about this, if I extend this line to become a diameter, this would now be 180 degrees, which would make that a 90-degree angle, even following that rule. All right, bottom one, now we have two secants going to a point outside of the circle. I think that's an L, not an I. But basically, L is going to equal 1/2. Since it's outside, we subtract. Since we're subtracting, order matters, and we have to do the big one minus the small one. And the big one's always on the other side. Continuing on, we now have two chords intersecting inside with segments. And that is just going to be segment times segment. So that'd be x times 3x equals 6 times 8. I'm not too worried about solving these. You guys can feel free to solve them, but I just want you to think of that because once you have this written down, I feel like you guys can solve these. All right, the very last one is 2 intersecting on the outside. This is kind of the slightly more difficult one because you have to get your whole measure. Remember, anytime you see this intersecting on the outside with segments, I do want you to say in your head kind of whole times segment equals whole times that exterior segment. So in this case, it'd be 6 plus x times exterior segment, which is 6, would equal 12 times 4. Once again, I feel confident you could solve those as well. The rest of the problems, so let's look at the problems really quick. I have them stapled wrong, so the ones without numbers, they're all pretty easy. I wanted to pick some where you actually have to use that radius thing like I talked about in class. The ones with actual numbers, so that's 1, 2, 3, and 4, they're slightly more difficult, but I think they're very, very doable. They're not like crazy hard out of the park. It's just basically getting you more practice because we do have 2 weeks off, and then we have a review, 2 days of review. So the more we review right now, the easier it's going to be to come back and look at this stuff. Yeah?
Oh, for those number ones, are we supposed to do proofs?
For number 1, are we supposed to do proofs?
Like number 4?
No, you don't have to do a proof on that one. Just actually find measure of AB and measure of CD. Yeah, I don't need any proofs on that. We didn't go through writing up theorems or something. So yeah, number 4, do not do a proof. It is just, I'm glad you brought that up and you didn't write a proof. No proofs on number 4. Just find the measure of AB, find the measure of CD. I'm also not going to check your homework because like I said, today is also